Hey everyone, let's jump right into this explainer. Today, we're unpacking a seriously fascinating conversation between Lex Friedman and particle physicist Don Lincoln. We're going to distill their deep dive into a focused journey, taking us from Newton's foundational laws to the absolute deepest, most mind-bending mysteries of modern physics. But before we pat ourselves on the back for our vast cosmic knowledge, consider this wild fact. Almost everything in reality, it's completely invisible to us. Everything you can see, touch, and interact with makes up only about 5% of the universe. It is a massive reality check. And understanding how we arrived at this realization is genuinely one of the greatest stories ever told. So, here's our roadmap for today. 1. The quest for unification. 2. The quantum revolution. 3. Time machines of science. 4. The dark universe. And finally, 5. Embracing the unknown. Let's kick things off with Part 1, the quest for unification, connecting the cosmos. Physicist Don Lincoln points out a really cool perspective, that the entire history of physics is basically just the history of unification. Science takes massive leaps forward when wildly different phenomena are suddenly revealed to just be different aspects of the exact same underlying principle. Look at how each era simplified nature. Back in the 17th century, Isaac Newton realized the force pulling an apple to the ground is the same exact force holding the moon in orbit. He literally unified earthly and celestial motion. Then, fast forward to the 19th century, James Clerk Maxwell proved that electricity and magnetism aren't separate things at all. They're two sides of the exact same coin, unifying them into electromagnetism. And then, of course, in the 20th century, Albert Einstein completely shattered our perception of reality by proving space and time are actually a single unified fabric called space-time, where gravity is really just the curvature of that fabric. Now, you might be wondering, why does this matter? Well, this brilliantly illustrates why these highly theoretical unifications are absolutely crucial to your everyday life. Maxwell's equations didn't just unify forces on some chalkboard for academics to debate. No, they gave us the foundational technology of the modern world. Literally every single time you connect to Wi-Fi, use your mobile phone, or turn on a TV, you are harnessing the immense power of electromagnetic unification. Moving on to Part 2, the quantum revolution, the subatomic world. So while Einstein was busy explaining gravity on this massive cosmic scale, a completely different revolution was zooming in on the unimaginably small. Because as it turns out, atoms aren't actually the smallest things in the universe. The standard model of particle physics maps out the true fundamental ingredients of reality. We've got quarks, which are the real building blocks of protons and neutrons. Then there are leptons, like the electrons buzzing around inside your atoms. And we have force carriers, like photons and bosons, which act as the literal messengers mediating the forces of nature. And the crazy part, every single major prediction mapped out here has been experimentally confirmed. Which brings us to Part 3, time machines of science, proving the theories. To actually prove the standard model, physicists literally had to build physical time machines to recreate the universe exactly as it existed just fractions of a second after the Big Bang. Now, the process is conceptually super simple, even though we're talking about humanity's most complex technology. Step 1, you accelerate particles to nearly the speed of light. Step 2, you smash them together at enormous energies. In Step 3, you observe the microscopic showers of debris to figure out the underlying structure. It's essentially like taking two highly intricate Swiss watches, smashing them together as hard as you can, and trying to figure out how they work just by looking at the gears that fly out. These incredible machines, built by massive global collaborations of scientists, have led to some truly historic breakthroughs. Over at Fermilab, the Tevatron discovered the top quark. And over in Europe, the CERN Large Hadron Collider made arguably one of the greatest discoveries of the 21st century, the Higgs boson, back in 2012. This literally proved the existence of an invisible field permeating all of space that actually gives atoms mass. Without it, stars, planets, and life simply could not exist. Let's jump into Part 4, the dark universe, the illusion of completion. So we figured it all out, right? Well, the grand clash of modern physics is actually this. General relativity describes the cosmic world of planets, stars, and gravity brilliantly. On the flip side, quantum mechanics describes the microscopic world of atoms and quarks perfectly. Individually, they're absolute masterpieces. But when you try to put them together, they create complete mathematical contradictions, especially when we try to look at the ultra-microscopic Planck scale. They flat out refuse to unify. And honestly, things get even weirder when you realize that empty space isn't actually empty. The Casimir effect proves this perfectly. If you put two metal plates extremely close together in a perfect, seemingly empty vacuum, they experience a measurable physical force. Why? Because that seemingly empty space is actually a dynamic, boiling sea of virtual quantum particles constantly popping in and out of existence. Realizing that nothing literally does not exist is just wild. But here is the ultimate reality check, bringing us right back to where we started. 5%. All of those atoms, quarks, stars, planets, and galaxies we just spent centuries figuring out, they only make up about 5% of reality. The math paints a staggering picture. The vast majority of our universe is dominated by phenomena we just simply do not understand. Like we said, 5% is ordinary matter, 25% is dark matter, and a massive 70% is dark energy. We are literally in the dark about 95% of the cosmos. So what does that actually mean for us? Well, dark matter essentially acts as the invisible glue holding our universe together. We know this because galaxies rotate far too quickly to be held together just by the gravity of the stars we can actually see, so there has to be an enormous quantity of invisible mass. Dark energy, meanwhile, is the strange force aggressively pushing galaxies apart at an accelerating rate. One pulls, one pushes, and we honestly don't truly know what either of them really are. Which leads us right to part 5, embracing the unknown, the future of physics. Confronting this kind of reality is definitely humbling, but for physicists like Don Lincoln, it's absolutely thrilling. We are so far from a complete understanding of reality, and we face massive unsolved problems right now. Unifying quantum mechanics and gravity, identifying dark matter, understanding dark energy, and explaining why our universe is made of matter rather than being instantly destroyed by an equal amount of antimatter. These are massive roadblocks. Yeah, but they're exactly what the absolute brightest minds on the planet are tackling right now. As the old saying goes, confusion is not a weakness. It is the starting point of discovery. Rather than feeling defeated that we only understand 5% of the universe, we should adopt the view that these mysteries are what inspire experimentation. Science doesn't thrive on having all the answers nicely wrapped up. It thrives on uncertainty, curiosity, and the courage to just say, you know what, I don't know, let's find out. So as we wrap up this explainer, I want to leave you with this one question to chew on. What will the next great unification reveal? From Newton's falling apple to the massive Large Hadron Collider, literally every generation has pushed the boundaries of what we thought was possible. We are standing at the absolute beginning of discovery, leaving us all to wonder what mind-bending reality is waiting just beyond the horizon. Thank you so much for exploring the grand unification with me today. Stay curious.